Let us talk about hemostasis. Hemostasis is a term that means the stoppage of blood loss. The goal of hemostasis is just to stop bleeding quickly and prevent the loss of vital body fluid. There are three stages in hemostasis: vascular spasm, which is considered a vasoconstriction. This can prevent blood loss and works for about 30 minutes. Basically, you cut off the flow of blood to an injured area by vasoconstricting the blood vessels leading to that. The second stage of hemostasis is called platelet plug formation. Uh, so the underlying layers of a blood vessel are made of collagen fibers. We'll talk a little bit in class about the three layers of blood vessels, but the underlying layers are made of collagen fibers. Those collagen fibers, when they're exposed due to injury, will attract platelets to themselves. When the platelets adhere to the collagen fibers, then usually they will stop a lot of the blood loss just by plugging up the hole. Okay, and the third stage of hemostasis is called coagulation. Coagulation is where you have, basically what happens is you have this protein called fibrin. It exists in the form of threads, and these threads act as a molecular glue, and they basically overlie the platelet plug formation and are very effective at making certain that the blood coagulates and no longer is able to leave from the area. Okay, when we look at coagulation, coagulation itself has three stages to it. So when we're looking at stage 1 of coagulation, it is called the production of prothrombin activator. This can go in about 10 to 15 seconds, so it's a very fast process. There are two ways that the production of prothrombin activator occurs. So let's look down at the bottom here. Here's our prothrombin activator. That is what we are going for in stage 1 of coagulation. On the left-hand side, we have what's called the intrinsic pathway. The intrinsic pathway it represents chemicals that are already present in the blood, intrinsic, inside of the blood vessel. This is actually quite a powerful way of allowing for prothrombin activator to be created. The other way that prothrombin activator is created is not as powerful. It's called the extrinsic pathway. The extrinsic pathway represents chemicals that are released from damaged tissues that are outside of the blood. So the extrinsic pathway and the intrinsic pathway both have the same goal. What you can see here is that there are mediary enzymes usually and some chemicals that are released from various parts, perhaps from the platelets, perhaps from structures within the blood itself. And oftentimes what will happen is they are simply activated. So we have this one that is called structure 12 can become activated to 12A. So that little A there means that it's an activated enzyme. Now that one in turn will cause 11 to be activated. And that one in turn will cause 9 to be activated, and so on. So whenever you see that subunit A, that means that it's an activated enzyme. Okay, so in a general sense, that is what happens for the first stage of coagulation, which is the production of prothrombin activator. What happens next is the prothrombin activator then is able to interact with, a structure called prothrombin. Prothrombin already exists inside of the blood, and it's one of the elements that you'll always find inside of the blood plasma. Prothrombin now is activated into prothrombin. Remember the first stage? Prothrombin activator. Here it goes. Here's our prothrombin, and we've activated it. So the first stage is the production of prothrombin activator. The point of prothrombin activator is to enact phase 2 of coagulation, which is the activation of prothrombin into thrombin. Next, thrombin is able to work on fibrinogen. Fibrinogen, which is also present in the blood plasma at all times at pretty high levels, is not a fibrinogen is an inactive form of something, and that something is fibrin. So what we want to do is we want to take our fibrinogen, activate it into fibrin. Fibrin then is able to form a mesh. So what activates fibrinogen into fibrin is the presence of thrombin, along with a few other things generally, but that's the basic idea. And then we have fibrin. Fibrin creates a network. It creates this webbing that looks a lot like a spider web, and that is how blood coagulates. Usually the fibrin will trap some of the red blood cells in the area. So fibrinogen is basically polar and is present inside of the blood at all times. When it is activated into fibrin, it becomes a thread, becomes very sticky. It tends to grab red blood cells. They tend to come down into the wound, and they're all trapped together. So coagulated blood usually looks red, although the coagulating agents themselves are not actually colored, as you can see that they're just thread-like. It's just that they happen to trap some of the formed elements, such as red blood cells, and that's what leads to coagulated blood looking, having the appearance of red. So again, just to differentiate, I want to review this because it's important. There are 3 stages to hemostasis: vascular spasm, platelet plug formation, and coagulation. If we look closer at coagulation, there's 3 stages to coagulation itself. The coagulation, the first stage is the production of prothrombin activator. The second stage is the production of thrombin, and the third stage is the production of fibrin, which finally forms a fibrin mesh.